going for a decode instruction. So your source register 2 will be read, but then your values or the new values will not be written back from your subtract operation. So that the kind of data dependency that it has created in the pipelining architecture. Yes, hope you got the point. We'll try to get into detail of how this is pipelining architecture, how it has been, how the data is being produced and consumed. So actually the data flow is that in the instruction, subtract instruction, it is going to produce the result during the third clock only. Yes. So this is instruction fetch, this is decode. Now after execution stage only your ALU will give an output. Okay, your ALU is going to give an output. So at the clock cycle 3 only, after the execution of this ALU, your subtract operation and the ALU only, here during this clock cycle only, your second register is going to be updated. Still the value is not available. Once it write backs only, the value is available in the second register, but the value is being generated at this third clock cycle. Yes. So AND and OR, if you see this AND and OR, they need the new value in their execution stage. So that is happening in their fourth and the fifth corresponding. You have to understand only during this fifth cycle, it is going to write back the value which is available here into the register 2. Yes, but then for executing the AND and OR, so for executing the AND operation in the fourth clock cycle, it requires the value in the second register, but it is not available. It is being available only in the fifth clock cycle. Similarly, for the execution of this instruction, it requires the value of the second register during the fifth clock cycle. During that time only, it has got the control signals to write back the value. So this write back value is dependent only on your fifth clock cycle. And you have to understand that this is not the one which is goes here during the stage is not an updated value. It is an older value. It is available, which is available in the second register. That problem that has been created due to this pipelining concept. So this is the case when you have data dependencies. So, but it is very similar to an approach of your single cycle or a multi-cycle if you are working on an independent instructions with respect to data and control. Okay. So now what we are supposed to do. So if we want to, this problem can be resolved. This problem can be resolved when you're trying to bypass the write back stage and the register read stage when needed, and then we are trying to make the data available immediately, then this hazard can be eliminated. Say for instance, if this memory write back and your memory write and your memory read and your write back problem of data hazard. So in this case, yes. So now what happens is that this is your pipelining register of your. So this is a pipelining register. So so where your ALU results will be written. So instead of writing into the data memory and then fetching the data address and then writing back to the register, your S2, what you do that you trying to bypass these two pipelining registers that contain the ALU result and just simply forward the value to the subsequent instruction using the pipelining register, then you are trying to eliminate this data hazard. So whatever I've highlighted, you can see. So instead of this can be neglected. So whatever is marked red is neglected, and only the ALU result which is available in the pipelining register is just forwarded forward to your to execute your next instruction. So data should be available, being updated immediately, which can be used by the next instruction. So problem of data hazard. So this is one way of doing it, which is called as a forwarding concept. We'll get into detail. So this is the forwarding outline of the forwarding hardware. So now, so this has got a forwarding unit that is going to select the correct ALU inputs to the execution stage. So that is the hardware concept of your forwarding unit. So if there is no hazard, then the but then if there is a data dependency and there is a data hazard, now the data will or the operands will come from, the inputs will come from the pipelining register. Either it can be from execute bar memory pipelining register or memory bar write back pipeline register. So this is directly from the pipelining registers we get. Well, so now the ALU sources will be selected by help of multiplexer. So there will be new multiplexing concept with your control signals being made. So these are the extra hardware components that is required. So one is your multiplexer, and now you should have new buses to route the data from your pipelining register to your muxes. So this is the concept of additional hardware requirements in order to go with forwarding architecture. Yes, now the data is not simply now the data is simply taken out from the pipeline register. It is directly going to the execute unit of your next instruction. So here it is been available, and this data is available here immediately. Yes, so forward, so you have the data from your is taken out from your memory bar write back pipelining register. So by the way of way or methodology of forwarding, we are trying to eliminate this data hazard. So this is a typical outline. So you had a hazard unit where the control signal is going to be generated, whether it is forward the muxes over here and the muxes and your corresponding wirings, control and the data wirings. So this is the extra additional hardware requirement in order to avoid or resolve the data hazard. Now we have a small problem when you are excuse me. Yeah. Yes, let's continue. So we have seen the concept of the usage of forwarding option in order to resolve your data dependencies. But we have still problems when we are working on with the load or store operation instructions. So forwarding is just not sufficient to solve your read after write or data dependency hazard. So this will when the when you're trying to solve a raw data hazard, when the result is computed in the, excuse me. So now, with respect to your forwarding is not sufficient in order to solve data dependency problem, which is created with read after write data hazard. When the result is just computed in the execute stage, so and the result is being forwarded to the execution state of the next instruction that we saw. So why? Because unfortunately what happened is that your load word instruction does not finish reading data until the end of the memory stage. Okay, so this that is the problem with your load word instruction and your store word instruction. So this load word instruction does not finish reading the data until the end of the memory stage. So it goes towards the end of the, so the result cannot be forwarded to the execution stage of the next instruction. Okay, so as you see, this load word, this in order to this load word is an immediate type of instruction. If you see, the output is available towards the end of the execution in your memory stage only. But when your execution is AND operation, it requires just you cannot pass it to the next instruction. So there is forwarding. But here, with this instruction with your load word, the output is available or it gets finished only after the memory stage. So, but then this cannot operation which is performing AND operation. So this cannot be forwarded to the execution stage of your next instruction, which is the AND instruction in this case. So we say that this load word instruction has got 2 cycle latency. It has got 2 cycle. There it was 1 cycle latency. Now it has got 2 cycle latency because of the very concept that the dependent instruction do not or cannot use the result for until 2 cycles later. So only after the result where this can be executed. So what you do in such cases where you have 2 cycle latency. So now this is the problem. So here you are using this register S0. So this S0 is available only in the memory stage of your this load word instruction, but it is being available or it is being required in the execution stage of your AND instruction, your OR instruction, as well as your subtract instruction. Well, so for this very concept, we have to go for the method called as stalling. Okay, which is nothing but your freezing of your operation. So now what happens? The load word instruction is going to receive data from the memory at the end of the 4th cycle, and then your AND needs the source at the beginning of the 4th clock cycle itself, and there is no way that we'll try to solve it via the forwarding option. So the alternate method or the next method where you have 2 cycle latency, then such problems are being solved by stalling the pipeline. So stalling the pipeline is that holding the operation until the data is being available. So that is the point here. So now as you see, this is the point over here. So this is the abstract pipeline diagram. So which is going to come with the concept of stalling. So one way or the alternate way to solve the data hazard. So this is an alternate option with your forwarding is not going to work. Then you're going for stalling the pipeline, which is merely holding up the operation until the data is being available. So now you can typically see the stalling is stalling the dependent instruction. So here the dependent instructions are going to be and your or. So we are not bothered about this subtract because it starts its execution after the completion of this entire cycle. So this does not becomes a problem over here. Only the instructions and or comes with the problem of this data dependency. So there you can see the stalling is, we are trying to stall the dependent instructions and decode stage itself. So we are trying to stop the operation immediately in the decode instruction stage. That is during your third class cycle itself, and stall there. Have start fourth cycle being stalled. So now what happens is that the subsequent instructions must, so all the instructions are in their say before stage. The subsequent instructions in the remaining operations all will be catching up from there. So that is from your fetch stage during both. So they'll remain in the previous stage, or they'll be frozen in the same stage where they'll be in the fetching stage during the both clock cycles. So that is what. So in the fifth cycle, what happens? The result can be after the results can be passed on or forwarded now from the write back stage of your load word to your execution stage of your and then this cycle 5 only, the source register of your OR is being passed on to your OR instruction, which is read directly from your, so with no need of forwarding. So here there is no need of forwarding, but here you need a forwarding. Yes, you got the point? That is the case that we are trying to go with stalling operation. That is freezing the operation for that particular moment of cycles until the data are being generated by the Okay, you understood? So you have to notice that the execute stage is unused in the cycle 4. Likewise, your memory is unused in your 5th cycle. And similarly, your write back is not used in your 6th cycle. You don't have the write back. So this is called as this unused stage that is forward or that is being propagated through the pipeline is called as bubble. Okay, it is something very similar to your no operation in your software programming. NOP, right? You write your no operation in your programs, right? It is very similar to that. So okay, so that is how you are trying to resolve your data dependency problem or data hazard in your pipelining architecture. Yes. So next class we'll see about control hazards and the way to resolve the control hazard. Clear to you right now? Any doubts?